Down there, life continues. The traffic is awful, stocks go on trading, and Star Trek is still showing.
day, grade 9 learners. Welcome to today's natural sciences lesson. My name is Patha Singo, and this lesson is proudly brought to you by the Harding Department of Education. In today's lesson, we're going to be learning under the knowledge area materials, and the topic for today is reactions of acids with metals. Reactions of acids with metals. All right, so now let us look at today's topic, reactions of acids with metals. And before we look at our lesson objectives, let's take a 1-minute break, and then we will return, and then we will get our lesson objectives. Okay, grade 9 learners, let's look at today's lesson objectives. By the end of today's lesson, you should be able to recap the properties of metals, explain the general reactions of acids with metals, describe the products of the reactions of acids and metals, and arrange metals according to their order of reactivity. And all of this is sourced from your CAPS document on page 68. Now let's move on to pre-knowledge. So this is what you've learned prior to today's lesson. It is basically laid down the foundation of today's lesson. Let's see what we have today. Right, so in the 9th grade, which is our previous lessons that we've been learning throughout this term, we learned the properties of metals. We also learned about acids and bases, their properties as well. And we learned about the reactions of acids and bases, and then we learned the reactions of acids and metal oxides. All right, so now let us move on to today's baseline activity. It's just a few questions that we are going to answer, and then I'll give you some time to answer those questions, and then afterwards we will do the solutions together. The first question is, list one observation that shows a chemical change is occurring in the diagram. So this is the diagram. There we go. Now, the diagram shows how crushed limestone in a test tube reacts when acid is added. So you need to refer to this diagram in order for you to answer your questions. And then the second question is, in order to be able to determine the density of an object's material that has both physical and chemical properties, what must be known about the material? What must be known about the material? And then the third question, cold drink cans can be crushed and reused to form new ones. Which property of metals makes it easy for this property? And then the last question is, why is gold used to manufacture jewelry? Why is gold used to manufacture jewelry? So I'm going to give you 5 minutes to answer these questions, and when we are done with our 5 minutes, we will go through the solutions together. So remember to send in your answers to 079-578-2908. I'm looking forward to seeing your answers after 5 minutes. Welcome back, grade 9 learners. Now let us look at the solutions. Let's go through the solutions together. Don't forget to send in your answers to 079-578-2908. Let's look at the solutions. So the first question read, list one observation that shows a chemical change is occurring in the diagram. So in the diagram, we had crushed limestone in a test tube that was filled with acid. So what is one observation that you can make to show that there's a chemical reaction? And it is the presence of bubbles. It is the presence of bubbles. Remember, bubbles are a sign that there has been a chemical reaction. They are evidence of a chemical reaction having occurred. Now, the second question is, in order to be able to determine the density of an object's material that has both physical and chemical properties, what must be known about the material? We should know its volume and its mass. You need to know the volume and the mass. If you remember from previous lessons and from the 8th grade, we learned that density is equal to mass divided by volume. So you should know its mass and its volume in order for you to determine its density. And then cold drink cans can be crushed and reused to form new ones. Which property of metals makes it easy for this property? It is malleability. So something that is malleable can be crushed and hammered and molded into shape. So the fact that we can crush them and remold them into new cans means that they are malleable. So that is one property that cold drink can metal has. And then the last question is, why is gold used to manufacture jewelry? Why is gold used to manufacture jewelry? The reason is because gold is malleable. It can be hammered into shape. That's why they make gold earrings, gold rings, gold studs, gold necklaces, lots of gold items that are jewelry because it is malleable. And the other nice aspect, or nice property about gold is that gold does not rust. Gold does not rust. It has a very low reactivity. Okay, so that was our baseline activity. I'm going to give you 1 minute to copy down the corrections and then we'll continue with our lesson. Welcome back, grade 9 learners. Now that you've copied down the corrections to the baseline assessment, let us move on to the next slide. In our next slide, we're going to be defining important terms that we're going to come across during the course of this lesson. These terms will help you to better understand the concept that we're learning today. Today, we have 4 terms that we are defining. Let's find out which terms they are. The first one is density. Do you remember what density is from the previous lesson? If you don't worry, I've got you. So density is the amount of mass in a given volume of a material. The second term is metal. What is a metal? A metal is an element that is malleable, ductile, and conducts electricity. The third term is acid. Do you remember what an acid is? These are substances whose pH ranges between 0 and 7. And then the last term, which is reactive. A reactive substance is one that vigorously gives off energy when reacting with other substances. It readily reacts with other substances. So those are the 4 terms that we have in today's lesson. Let's move on to the next slide. So we're going to recap on acids. That was our first objective. We're going to recap on acids. Let's remind each other what we learned about acids. So we learned that an acid is a substance that whose pH is between 0 and 7. An acid is a substance whose pH is between 0 and 7. And an acid is a solution that has an excess of hydrogen ions. How do we represent hydrogen ions? We write H plus. There we go. We write H plus. And that comes, the name acid actually comes from the Latin word sour or sharp. Sour, sharp. Because acids generally have that sharp or sour taste. Have you ever tasted vinegar? That taste. Vinegar is actually an acid. Have you ever tasted it? If you haven't, just try and taste it, then you get that sour and sharp taste. That is an acid. All right. So now, the more hydrogen ions, the more acidic the acid solution. So that's how we have acids having a range of pH, like ranging from 0 to 7, between 0 and 7, and them having different pHs is because of the number of H plus ions. So the more H plus ions there are in an acidic solution, the more acidic it is. So that's how they are different acids with different pHs. Okay. So now let's move on to properties of metals. We're also recapping on the properties of metals. Do you remember them? Okay, let's go. So one of the properties of metals, what are they? So a metal generally is an element that is malleable, ductile, and conducts electricity. And some examples of metals are iron, copper, and zinc. So these are some examples of metals. They are iron, copper, and zinc. And their symbols on the periodic table. So the symbol for iron is Fe. Always remember to start off with a capital letter. The symbol for copper is Cu. Always remember to start with a capital letter. And the symbol for zinc is Zn. Those are the symbols for the examples that we just had. So metals are found on the left-hand side of the periodic table of elements towards the middle. There's quite a number of them. I've got a periodic table. I'm just going to zigzag around the metals and show you where the metals are. And then metals, we said metals are ductile. So you see those copper wires there. They can be drawn into wires. So those were some of the properties of metals. And they are malleable. They can be hammered into shape. That's why you have shapes of nails, shapes of metal chairs, different materials that are made of metal because they can be hammered into shape. So that is one of the good properties of metals. And there are some bars there. You see, they have been hammered into a certain shape. Okay, let's move on. Properties of metals. Okay, so metals are sonorous. Metals are sonorous. Do you remember from last week what sonorous means? It means they are able to produce a sound. That's why at school they have a metal bell. And no matter which part of the schoolyard you are at, you will be able to hear that metal bell because metals are sonorous. The other property for metals is that they are ductile. What does that mean? It means they can be drawn into wire. They can be drawn into wire. And then they are malleable. What does malleable mean? They can be bent. They can be hammered into shape. They can be bent. So that is one of the properties. And then they are also quite shiny. They are also quite shiny. I've got some shiny balls there. They are also quite shiny. That's another property of metals. And they have high tensile strength. That's why most of the chains that you see, they are made of metal because they can withstand any kind of tension. So they have very high tensile strength. So those are some of the properties that metals have. Remember, I said I have a periodic table and I'm going to show you the location of metals. So there is the periodic table of elements. I'm sure you remember it from the 7th grade and from the 8th grade and from the 9th grade. So our metals, we said we find them on the left-hand side of the periodic table. There we go. So that is our left side. I'm going to zigzag. Okay, so this whole area here, the left-hand side, that's where we find our metals. So anytime you come across a periodic table, try and pick one metal or two. That's where you find the metals on the periodic table. So another objective of ours, we should be able to describe the reactivity of metals. So just like bases have a different pH range, acids have a different pH range, metals are also different in the way that they react with other substances. So they can be graded according to how reactive they are or how they react with other substances or how readily they react with other substances. So I've got a table here from the least reactive metal to the most reactive metal. So we'll start here at the bottom. So platinum is the least reactive metal, whereas potassium is the most reactive metal that we have. So if you see, just look at the color. Look at the color as it gets darker and darker and darker. It shows us how metals are the least reactive. So if we look at here, if we start here from copper, all the way down to platinum. So copper, silver, gold, and platinum are part of the least reactive metals. Examples, just look around at home or your classroom. That's why we have copper. We use copper for our water pipes because it's not quite reactive. So chances of it rusting and us getting sick from drinking contaminated water are less. Silver, that's why we have silver cutlery and silver jewelry. Gold as well, it's not quite reactive, that's why we use it for jewelry. And then platinum as well, it's not reactive, that's why we use it in jewelry and other instruments that we use it for. But when we come up here higher with potassium, calcium, and sodium, these are very, very active metals. They're quite reactive. Any exposure to air, they turn into oxides. So they are quite reactive metals. So that is our reactivity of metals. Let's move on to the next slide. So now we're going to talk about the general reactions of acids with metals, which is the topic for the day. Acids with metals. Okay, so when a metal reacts with an acid, its products, it produces a salt and hydrogen. It produces a salt and hydrogen. So that is what happens when a metal reacts with an acid. So the type of salt that is formed depends on the specific acid and metal that is used. So there is no one general salt, and but there is also one general product. The second one is hydrogen. So the type of salt now, it depends. It highly depends on the type of the acid and the type of the salt. So I'm just going to give you a minute. Just try and figure out the general equation, word equation for the reaction between acids and metals. The general word equation for the reaction between acids and metals, and then after 1 minute, we will go through it together. Welcome back. I hope you sent in your answers to 079-578-2908. Let's look at what we have. What's the general equation? So the salt is named after the acid and the metal. But what is the general equation? There we go. So it is metal plus acid on the reactant side. Remember, reactants are found on the left-hand side of the arrow. And then we have a salt and hydrogen as our products. So our reactants are a metal plus acid and to give us a salt and hydrogen. So now the identity of the salt. The identity of the salt is dependent on the type of the acid and the metal that is used. So it is named after the acid and the metal. So a combination of the two. So now I've got some quick questions that I want us to go through. So the first question is, if an acid is added to a fairly reactive metal, what will happen to the metal? And the second question is, how can we tell a reaction is happening? And then the third question is, are all metals reactive? Can you give examples of less reactive metals? All right, so I'm going to give you 3 minutes to answer these questions. Welcome back, grade 9 learners. I hope you're sending in your responses to the number 079-578-2908. So let's look at the solutions. So the first question read, if an acid is added to a fairly reactive metal, what will happen to the metal? So the response is, when acids react with metals, they produce a salt and hydrogen gas. Remember from our general equation, the one in the previous slide? Yeah. And salt and hydrogen gas. So how can we tell that a reaction is happening? The answer is quite long, but let's go through it. So if there is a reaction, a chemical reaction, we can tell by the following signs. The first sign, if there's a change in color, then you know there's a reaction that is happening. The second sign is if there's a change in temperature. Some reactions give off heat, some reactions take in heat. So if there's a change in temperature, then you know that there is a reaction happening. So heat is released and absorbed during a reaction. So now if there's a formation of a gas, then you know that a reaction is happening. How do we know that there's a formation of a gas? We know through bubbles. Bubbles are released during that reaction. Sometimes you may not really see the bubbles, but if there's an odor or you can smell something different, then you know that there has been a gas that has been formed. Another way you can tell if there has been a chemical reaction is formation of a solid. If there's a solid that is formed after two substances are mixed and they react chemically, then a solid will be formed. We call that solid a precipitate. We call that solid a precipitate. And the solid will settle out of a liquid solution. So it's easily identifiable. It's quite distinct. It's different from the liquid and you can easily see it. Remember that solid is called a precipitate. And then the last question is, are all metals reactive? Can you give examples of less reactive metals? Yes, there are, but they are not on the same scale. Remember that table of the activity of metals where we had the most reactive being potassium and the least reactive being platinum. They're all reactive, but their reactivity is different. The least reactive ones from the table are copper, platinum, silver, and gold. These four are not as reactive as calcium, magnesium, and potassium. They're not as reactive as those three. Okay, so now let's talk about hydrogen gas. Hydrogen gas is a clear indication that there has been a reaction. It's a gas that is formed when an acid reacts with a metal. So when acids react with metals, they produce hydrogen gas. So let's see examples of equations, both word and symbol equations of reactions with metals with different acids. So now the reaction between hydrochloric acid and magnesium. So here are the equations. We'll start off with the word equation. We'll start off with the word equation in our example. So this is the word equation. So hydrochloric acid reacts with magnesium to produce magnesium chloride and hydrogen. Remember when we said this name of the salt will depend on the metal and the acid. So the name of the salt is actually named after the metal and the acid. This is our salt. That's the salt there. Right? We said salt and hydrogen. So this is the salt. So we named the salt after the acid and the metal. The metal is magnesium, so it forms the first part of the name. And the acid is hydrochloric acid, so we call it magnesium chloride. And then the second product is hydrogen gas. Now let's look at the balanced equation for the symbol equation. Okay, so we have hydrogen chloride reacting with magnesium to give us a salt, which is magnesium chloride and hydrogen gas. Why do we write H2 for hydrogen gas? Hydrogen occurs naturally as a diatomic molecule. So it has two atoms to make up the molecule that are bonded together by a chemical bond. So we have our H2 hydrogen gas there, and then this is the symbol for the salt, the magnesium chloride, Mg for magnesium from your periodic table of elements, and chloride. So we have two chlorine atoms bonded to one magnesium there. So that is our example. Let's look at more examples of where hydrogen gas is produced when metals react with acid. Our second example for the day is going to be sulfuric acid and zinc. So now let's look at the word equation. Let's look at the word equation. So the word equation is sulfuric acid reacts, remember this is how we read word equation. Sulfuric acid reacts with zinc to produce zinc sulfate and hydrogen. To produce zinc sulfate and hydrogen. How did we name our salt? We named our salt zinc and sulfate. So it is named after the acid and the metal. So the name of the salt is zinc sulfate. So now let's look at the balanced symbol equation. Let's look at the balanced symbol equation. There we go. We've got sulfuric acid. So that is the chemical formula for sulfuric acid. Reacts with zinc. There's the symbol for zinc giving us zinc sulfate. So this is how we write zinc sulfate and hydrogen gas. Don't forget the 2 there next to the H because hydrogen exists as a diatomic molecule. So don't forget the 2. And then our third example is when we are reacting hydrochloric acid and sodium. And the word equation is as follows. I'm going to put up the word equation now. So the word equation is hydrochloric acid plus sodium to give us sodium chloride plus hydrogen. Do you remember what sodium chloride is? Sodium chloride is our common table salt. So let's look at the symbol equation for sodium chloride. So we've got hydrogen chloride and sodium to give us sodium chloride and hydrogen gas. So that is the balanced equation for the salt and hydrogen that are formed when we react sodium and hydrogen chloride. Right. So now let's look at today's activity. So we're going to be focusing or we're going to be referring to the equation in the text box. We're going to be referring to the equation in the text box. The equation in the text box is metal reacts with acid to produce a salt and hydrogen. So one example here is sodium reacting with hydrochloric acid to give us the salt, sodium chloride, and hydrogen. So there we go. So you need to copy and complete the following reaction. So I'm going to give you 4 minutes to complete the following word equations. Complete the following word equations for the salts and metals that are reacting. I'm going to give you 4 minutes to do so. Welcome back, grade 9 learners. Now let's look at the solutions to the questions. So the question is copy and complete the following reactions. So we've got iron and hydrochloric acid. So iron and hydrochloric acid produce iron chloride and hydrogen. So those are the products when we react iron and hydrochloric acid. Let's see, what will we get when we react zinc and hydrochloric acid? We will get zinc chloride and hydrogen. We'll get zinc chloride and hydrogen. And then when we react copper and hydrochloric acid, we get no reaction. We get no reaction. Remember our reactivity series? Do you remember it? Copper is not quite reactive. And then when we react magnesium chloride and hydrogen, if we get magnesium chloride and hydrogen, we will get magnesium chloride and hydrogen. Okay, so these are the reactions. I hope you're sending in your answers to 079-5782-908. There's a team here that is ready to assist. There's a team that is ready to assist. Now let's move on. So let's talk about hydrogen gas. Let's describe hydrogen gas. Hydrogen gas is one of the products that we get when we react an acid with a metal. Let's talk about hydrogen gas. So hydrogen is an element. You've seen the periodic table. It's represented by the symbol H. It has an atomic mass of 1. Hydrogen is an element that naturally exists as diatomic molecules. And this means that hydrogen is actually not made up of single atoms, like naturally. It is not made up of single atoms, but exists as a molecule. It exists as a molecule, so we call it a molecule of an element. So each molecule of hydrogen consists of 2 atoms that are bonded together. They are bonded with a chemical bond. Remember from your 8th grade, a chemical bond is the force that holds 2 atoms together. So the formula for hydrogen gas is H2. That's why when we're writing the symbolic chemical equations, we kept writing H2 because it exists naturally as a diatomic molecule. So there is our hydrogen molecule. We have 2 hydrogen atoms, 1 and 2. So naturally, this is how hydrogen exists. Let's move on to the next slide. So hydrogen has a lower density than air. It has a lower density than air. It is actually the gas that has the lowest density that we know. There could be some more that we haven't discovered. So that is the density of hydrogen, 0.899 grams per cubic centimeter. 0.899 grams per cubic centimeter. That is the density for hydrogen. So hydrogen doesn't have a color, so it is colorless. It has no color and it doesn't have a smell. It has no color and it doesn't have a smell. And it reacts vigorously with oxygen. It actually reacts vigorously with oxygen. And that reaction between hydrogen and oxygen gives off water. It gives off water, or it produces water. Other than water, it has other product. It gives off heat, light, and sound energy. So there is a sound, there is a light, and there is heat that is produced as well as water when hydrogen reacts with oxygen. So there's an image there, a short video just to show you this vigorous reaction that hydrogen has with oxygen. What happens when hydrogen reacts with oxygen? There we go. You see in that balloon, we've got oxygen and then we introduce hydrogen. Look at what happens, that vigorous, violent reaction that happens. Let's continue with our description of hydrogen gas. I just want to zoom in, and since hydrogen gas doesn't have a color and doesn't have a smell, then how do the scientists know that hydrogen gas has been produced? How will the scientists be able to tell that hydrogen gas has been produced? So this is how. So there's a test that scientists perform, a test that scientists do when they want to find out what gas it is. Since hydrogen, you can't smell it, so there's no odor, and you cannot see its colors, so you cannot identify it. So now, how do we know that when a metal reacts with an acid, a hydrogen gas is produced? There's a simple test that they do. If hydrogen gas is there, they bring a lighted splint towards the gas, and then there's going to be a squeaky pop sound with a lighted split. So that's how scientists know that hydrogen gas has been produced. So remember that in case it comes in your exams. Remember that in case it comes in your exams. So now let's move on to our second activity for today's lesson. I'm going to read out the questions and then give you time to answer the questions. So the first question reads, write the simple chemical equation in the reaction between hydrochloric acid and zinc. And the second question is, when an acid reacts with the metal, a salt and blank gas forms. So you have to fill in that blank there. And then the third question is, a molecule that consists of two atoms bonded together is called a blank molecule. Fill in that blank there. And then the fourth question is, when an acid reacts with the metal, do you think the pH of the solution decrease or stay the same? Explain why. So here you're bringing all your knowledge of acids, bases, and different reactions. So I'm going to give you 5 minutes to answer these questions. Welcome back, grade 9 learners. Now let's go through the solutions. So the first question read, write the simple chemical equation for the reaction between hydrochloric acid and zinc. So there is our equation. There is our equation between hydrochloric acid and zinc. So now that we have our equation, now let's balance it. Let's balance it together. So we have HCl plus zinc to produce zinc chloride plus hydrogen. Zinc chloride plus hydrogen. How do we balance the equation? So zinc will borrow 2 chlorine atoms. So zinc will borrow 2 chlorine atoms. And then here, hydrogen gas is a diatomic molecule. Hydrogen gas is a diatomic molecule, so we put a 2 there. So now we have to make sure the number of atoms on the right-hand side is equal to the number of atoms on the left-hand side. So there we go. We have 1 zinc on the right-hand side. So we have also 1 zinc on the left-hand side. We have 2 chlorine atoms on the right-hand side. So we need 2 chlorine atoms on the left-hand side. So we'll put a big 2 next to the hydrogen. And then we have 2 hydrogen atoms on the right-hand side and 2 hydrogen atoms on the left-hand side. So there is our balanced equation. There's our balanced equation. And then the second question reads, when an acid reacts with a metal, a salt and blank are formed. A salt and blank gas are formed. So we form hydrogen gas. Hydrogen gas. I'm sure you got that clue from the first question. And then when a molecule that consists of 2 atoms bonded together is called a blank molecule. It's called a diatomic molecule. It is called a diatomic molecule. And then the fourth question is, when an acid reacts with the metal, do you think the pH of the solution will increase, decrease, or stay the same? Explain why. So the pH will increase. Why are we saying so? In the reaction, the acid is changed into something else, but it is not an acid. This means that the pH will increase. So remember, the pH of acids ranges from 0 to 7. So if an acid is changed to something else, it means that the pH is going to increase. The pH is going to increase. So now let us summarize our lesson. So the important general equation for the day is acid plus metal produces a salt and hydrogen gas. So this is the general equation for the reactions of acids with metals. Acid plus metal gives you a salt and hydrogen gas. All right. So metals have their own properties. If you remember from the beginning of our lesson, we said they are malleable, they conduct electricity, they are ductile, they are shiny, and they are sonorous. So metals have important properties. And then another fact about metals is that metals react with acids and they produce a salt and hydrogen gas that we have derived from our general equation at the bottom there. So acids react with metals to produce hydrogen gas. Now the type of salt produced depends on the metal and the acid used. So sometimes the acid is sulfuric acid and sometimes the acid is hydrochloric acid. You can't have the same salt being produced. So the salt that is produced depends on the metal and the acid that is used in the reaction. And then the salt is named after those two that I've just talked about, the metal and the salt that is produced. And remember the general equation between in a reaction between acids and metals is metal reacts with acid, that's metal plus acid, to produce the arrow pointing towards the products, a hydrogen gas and a salt. Hydrogen gas and a salt. So that is the general equation for when metals react with acids. Now let's move on to the next slide. Now, properties of hydrogen gas. We learned about a number of properties of hydrogen gas in today's lesson. Hydrogen gas has a lower density than air, so naturally hydrogen gas will float above the air, or a balloon of hydrogen gas will actually rise up to the top. Hydrogen gas has a lower density. If you remember, it's 0.0899 grams per cubic centimeter. We also know that it is the gas that has the lowest density that we currently know. Since you're upcoming scientists, maybe you will discover more gases, okay, more elements of gases. And then hydrogen gas does not have a color and does not have a smell. So it has no smell, no odor, and it doesn't have a color. So that is the other thing that we remember about hydrogen gas. And then do you remember how scientists test for hydrogen gas? They use a glowing splint, and the positive result for hydrogen gas, for it produces a squeaky pop sound with a flame. There's a flame and a squeaky pop sound for hydrogen gases. Hydrogen gas reacts violently or vigorously with oxygen. Do you remember the balloon that I showed you that burst into flames? So that's how hydrogen gas reacts with oxygen. And that reaction actually produces water, sound, light, and heat energy. Water, sound, light, and heat energy. So that is the product. So here's the homework. Here's homework. I'm going to read it out for you. I'm going to read out the homework. Now, write a word equation for the following metals with hydrochloric acid. Write a word equation for the following metals with hydrochloric acid. So here they are: lead, aluminium, and tin. So that is your homework. That is your homework that you need to do. And then thank you so much, grade 9 learners, for joining me in today's lesson. I hope you learned a lot. Don't forget to sanitize, wear your mask, and keep social distance. And enjoy the school term holidays. Until next term, bye-bye.